Hey all, today we will be doing the last new lesson of the year, and we're going to talk still about solids, but we're going to talk now about similar solids. So we can relate these two similar solids using a scale factor that we'll call A over B. We talked about scale factors a little bit with dilations and also similar triangles. The new idea here are the ratios of the areas and the volumes. If you know what the scale factor of these two similar solids is, A over B, then you can find out what the ratio of their areas is and the ratio of their volumes. Meaning, we can find out the fraction that represents dividing the areas of both of these and the volumes of both of these. To get the ratio of areas, we square the scale factor, so we square A and B. To get the ratio of volumes, we cube A and B. And we can go from one to the other to figure out some measurements. So here I know the surface area of these two similar cylinders. So I can write the ratio of their surface areas, 7 pi divided by 175 pi. And that's equal to A squared over B squared, since the ratio of the areas is A squared over B squared. So if I want to find the scale factor A over B, I'll first cancel out the pi's, so we don't have to deal with pi's. And then I can square root both sides, because I want to get rid of the squareds. When I square root A squared and B squared, I get A divided by B. And now I'm going to simplify 7 over 175. If you don't know how to find a common factor of 7 and 175, you can always put this fraction into your calculator and then math frac the decimal. You'll get 1 over 25. Now I can take the square root of the top and the bottom. The square root of 1 is 1. The square root of 25 is 5. And we find that the scale factor here is 1 over 5. If I want to find the ratio of volumes now, so that I have all three, I can cube A and B, which means I do 1 cubed over 5 cubed, which is 1 over 125. I can do the same thing if I'm given the volumes. I can find the scale factor in the ratio of surface areas. I can write the ratio of volumes. That's equal to A cubed over B cubed. Then I can cube root both sides. If I cube root a cubic, it cancels. So cube root of A cubed over B cubed is just A over B. And then I simplified this 10,240 over 20,000 by putting it in the calculator and then math fracking. I get 64 over 125. The cube root of 64 is 4, and the cube root of 125 is 5, and this is my scale factor. If you don't know how to do that, I can show you in class how to do the cube root on the calculator. If I want the ratio of surface areas, I just square A and B. So I square 4 and 5, and I get 4 squared is 16, 5 squared is 25. This is my ratio of surface areas. And I'll say this, if I know the ratio of surface areas, and then I know one of the object's actual surface areas, I can create a proportion to solve for the other 3D figure's actual surface area. And we'll do some of that in class. So I want you to pause here, and I want you to find the scale factor of these two similar figures, and also the ratio of volumes. So I'm going to write the A squared over B squared, square root both sides. I get A over B to be root 25 over 36. The square root of 25 is 5, and the square root of 36 is 6. That's my scale factor, 5 over 6. To get the ratio of volumes, I cube both of those, and I get 125 over 216. So for your you-do, I want you to find the scale factor of these two similar 3D figures and also the ratio of surface areas.